This lecture is on specific heat and energy. Question: what is specific heat? Specific heat is another word for specific heat capacity, in which is the quantity of heat needed to change the temperature of 1 gram of substance by 1 degree Celsius. To the left are some common specific heat capacities for both liquids and solids. Solving for heat can be done by the following equation. Q equals M times C times delta T, where Q represents heat, M represents the mass of the sample, C is the specific heat of the sample, and delta T is the change in temperature between T final and T initial. Here's a sample question for you to ponder. Suppose you have a range and you have the option to get one of 3 different metals to use: aluminum, copper, or iron. Which metal would you use and why? Pause the video if you would like to try the problem. Press play to continue. Specific heat of aluminum is 0.903 joules per gram degree Celsius. Specific heat of iron is 0.452 joules per gram degree Celsius. Specific heat of copper is 0.385 joules per gram degree Celsius. In accordance to the equation, Q equals M times C times delta T. And after rearranging the equation, delta T equals Q divided by MC. Since delta T and C are inversely related, the lower the specific heat is, the higher the delta T. And since it is less resistant to temperature changes, the best metal to use is Cu, or copper. You may face word problems in solving for Q, M, C, or any form of T. Let's look at some examples. Sample problem 1 is: how much energy is required to change the temperature of 15 grams of iron from 18.5 degrees Celsius to 56.8 degrees Celsius? The specific heat of iron is on a previous slide in this lecture. Pause the video if you'd like to try the problem. Press play to continue. What's given is that the mass of the sample is 15 grams, T initial is 18.5 degrees Celsius, and T final is 56.8 degrees Celsius. The equation is asking to solve for Q, or heat. One needs the specific heat capacity of iron, which is 0.452 joules per gram degrees Celsius, and delta T. Delta T equals 38.3 degrees Celsius. The solution map is Cm and delta T, and next is Q. After plugging in the numbers in the equation, Q equals 260 joules, and it has 3 significant figures in its answer. Sample problem 2 is if 34.8 joules is required to change the temperature of 10 grams of mercury by 25 degrees Celsius, what is the specific heat of mercury? Pause the video if you would like to try the problem. Press play to continue. The given information is mass equals 10 grams, del T equals 25 degrees Celsius, and Q equals 34.8 joules. One needs to find the specific heat capacity, C. The solution map is Q, M, and del T, and eventually obtaining C, or specific heat capacity. After plugging in the numbers, C for mercury is 0.139 joules per gram degree Celsius. Here are some review exercises for you to work on. Please solve each of the following problems. 1. A copper pot absorbs 3.6 times 10 to the 3 joules of heat as the temperature changes from 54.5 degrees Celsius to 75.0 degrees Celsius. What is the mass of the pipe in grams? The specific heat is in this lecture. See previous slides. 2. As the sun shines on a 2.00 times 10 to the 3 gram concrete slab, the slab absorbs 5.6 kilojoules of energy. What will be the change in temperature, or del T, as it occurs? Specific heat capacity of concrete equals 0.880 joules per gram degree Celsius. Three, how much heat is absorbed by a 2.0 times 10 to the 3rd gram iron skillet over a campfire as it goes from 25 degrees Celsius to 2.00 times 10 to the 2 degrees Celsius. For the remaining part of this lecture are solutions to review exercise or problems. Please view only after completing these exercises.